This is DirectX graphics development with Microsoft Visual Studio 2012. I am Eric Battaglio. I work on the Visual C++ team at Microsoft. I work mostly with communities, but I do influence the rest of the team, trying to make sure that scenarios from people like you are represented in the product. So TechEd has been a great opportunity for me to learn from quite a few of you in the Visual Studio booth about what matters to you with native development. It turns out there are a lot of folks that are out there with large legacy code bases, millions of lines of code, and that's just an eye-opening thing that sometimes we forget that there's piles of code out there. We tend to always look forwards. Let's go do the next thing. So that's been great. Anybody know what this is? Halo. So this is not a session about games. So let's just get this out of the way. Halo, it's incredible. One thing that I've learned by preparing for this session, because I was not a graphics guy, but going through some of the tutorials we have and learning online and from others, it is complicated to write something like that. I mean, you've got thousands, if not millions, of things going on and a lot of complicated logic. It's one thing to be able to render a robot. It's quite another to make it smart enough to shoot you. And so it gave me a newfound respect, slogging through code and playing with the designer, that it's one thing for me to go out and render a cube. A game like this takes a lot of time and effort. So I'm going to give spoilers. These are not Game of Thrones spoilers, so those of you who haven't seen the last few episodes of Game of Thrones, you're fine. You should go watch them or read the books. DirectX is not just for games. It is a suite of multimedia APIs, includes sound, inputs, audio, and interface with hardware like Connect. Visual Studio in 2012 and DirectX can help you create unique store apps that might differentiate your app from everybody else's app. So if you're publishing out to the store or you're making any kind of application, there might be an opportunity for you to kick it up a level, right? And from a business perspective, that might mean a unique visualization against some data you have, or an interesting way to interact. Maybe you're going to use Tilt or something, maybe Connect. And Visual Studio 2012 makes it easy to manage your graphics assets. So images, shaders, things like that. The Visual Studio will certainly help you with that. And there's debugging. And so there is a quiz at the end. And I'm not going to say what's on it, but customers have had a hard time figuring out how to launch graphics diagnostics tools. That's as soon as I got this session, a few people said, well, how do you launch it? Make sure you tell people how you launch it. Alt F5 is a keyboard shortcut. So if at the end of this you walk out of here with just one thing, and it's Alt F5, then I consider that a success from that perspective. And I'm going to ask you to join the community at the very end when I point you to other resources. I am a community person. I've spent quite a lot of my time working with IT pro communities and now developer communities, both as an IT pro and as a developer. And do not underestimate the intelligence and power of the people that participate in community and their willingness to help, and hopefully your willingness to contribute to those communities and share what you've learned. Even if you think it's something that no one else is interested in, you would be very surprised that your scenario is actually more common, and someone out there will really appreciate you sharing. So I'm going to give you an overview of DirectX. Then I'm going to build a sample proof of concept app using C++. I'm going to start from the Explorer, and I'm going to use a 3D starter kit variant, and I'm going to unpack that, and I'm going to go from there. So I don't necessarily have a net, so if bad things happen, we'll fix them. We're going to debug an app. Of course, it's contrived. I went in and introduced bugs, so there's another instance of the demo that I've got already loaded that I've introduced some bugs into. So I'm going to tell you right now, I did it. But they are based on what commonly are bugs. So when people use DirectX, one of the things that comes up as a bug is a file that's specified to be loaded, like a mesh or some other object, is just not specified right. Either it's the wrong name or the file can't be found. Right? I was really surprised. I thought the errors would be, oh, it's got to be some weird pixel or the shader complexity. No, one of the more common errors is it doesn't find the file. So we're gonna debug our app. We're gonna think about ways that we can extend that application. So, what makes a good app? Any ideas? I'm sure there's lots of ideas. You guys probably have lots of apps. What attracts you to the apps that you use the most, other than necessity, like the email app? User experience? Easy to use. Fast and fluid. Bug-free. What you say. Yeah, a great experience. So you guys got a lot of these. It just works. It offers a unique experience. In some cases, that's what people are going for. Smart interaction. When I was younger, I liked troubleshooting. I loved playing with cables and tracing things down when they didn't work. Now, my most common complaint is whatever I'm looking at, if it's not working, why won't you just work? Save my stuff over there so I can get it over on the other machine, right? Just do it. Assume. Take smart default. Please, you're killing me. So here's an example of a great app in terms of multimedia here. This is Fresh Paint. I've used it. I've seen videos of kids using it. My kids have used it. It's a great experience. It uses DirectX and offers unique interaction, I think, that really sets it apart. So I'm sure, hopefully if you guys have Surface, this is an app that you've gotten. It is free. Definitely take a look. It's fun to use, and it's pretty easy to draw stuff, at least basic stuff. This application shows interaction. If you take a closer look at this, I'm not going to demonstrate it because I'd probably break something. But it uses a camera when it projects you into the screen and you're supposed to interact to hit things, right? So you're supposed to stretch and do cardio type workout. It's unique with an interesting display there. So it mixes real-time interaction and graphics and sounds. And this is an app that's used for education. It's a simulation of chemistry lab. It's something I'm going to go into a little bit further here in a minute. So educational. DirectX can help you do these things. It's a multimedia API, not just graphics. I think I mentioned that. People think graphics, but it includes 2D, 3D, DirectX Math, audio, X-Audio 2, and X-Input. If you're interested in the X-Audio part, I can shill for MSDN Magazine. Charles Petzold has been writing a series of articles using audio too. So if you're interested in those types of things, in fact, I think he's creating a synthesizer. So definitely check out MSDN Magazine if you want to follow along there and learn more. Our current version is 11.1. I know there's a lot of other versions out there too. So here's what it looks like for DirectX for Windows developers. We have 11.1 support for Windows Store and desktop apps. And we've got Visual Studio tooling for quite a bit of these. But you can see that for a graphics application that you've got a lot of other things that are involved other than just graphics. You've got game input, I've mentioned, and then the platform itself will offer storage and some of the other things you need to create your application. We are going to focus here today. So I'm going to switch to a demo. Let's hope everything works here. There it is. The window screen. This application is a virtual experiment laboratory. So it shows physics, chemistry, and biology concepts using DirectX. And I thought it was interesting because it's hands-on and it's kind of a practical application. Again, not a game, a little bit more practical. So I can come in here and learn about oscillation. It's asking me to try it here, so I'll go to 22. And then practice our patience as it slows. I did it all the way once. It took about a minute. I figured that probably wouldn't work here, although for comedic purposes, I know Family Guy uses that sometimes. The joke will go on for an hour, and it's funny anyway, right? It's like, when is it going to end? So this is going to go a little quicker. But you can see they've got the physics. They've got objects in here. Wow, this is going a little bit longer than I thought it would. Excellent. So it finished. It said it took 27 seconds. What it's going to have me do now is it's going to shorten the rope and ask me, is it going to go same amount of time if I shorten the rope with the same weight? Is it going to be shorter or longer? Anybody know the answer? Shorter? Same? Continue. So if I double click, there it goes. And then I got to go to angle 22 again. Let's see. At least this way I can't blow up the lab accidentally, right? Or spill chemicals. or, I don't know, when I was a kid, I wasn't too thrilled about cutting open the frog either. So let's see. I was not correct. It was shorter. So same weight, shorter rope, takes shorter amount of time. Now they're making the weight actually smaller. What will happen? So with less mass, is it going to be shorter, longer, or the same amount of time? Same amount of time. Bam. Go to angle, click. There you go. We're going to get this one right. Good work. There we go. So this is an example. There's one other one I wanted to show here because I thought it was just kind of cool. Here, I'll just pick carbon. I can check out the atomic structure here. So neat. So that's an example of the virtual experiment laboratory, developed by Gokhan Sengun. He's a good guy, and as I'll mention later, we talked to him on Channel 9 about this application, and he shared some of the secrets about some of the things he did, including a pixel shader, some of the pixel shader development he did, and sprites. So that's what's kind of nice about the demo. When I work through a sample here, there is a lot of support material online, and I will point you to that. You don't have to start from scratch when you build an application with DirectX. There are templates in Visual Studio 2012. There's quite a few templates. Windows Store, Windows Phone, we've got C++ XAML. We've got a lot of applications out there. We have a lot of content to support that and examples and smart people talking about them. There are samples, over 80, and growing. I'm sure the community is contributing more to that. There's a DirectX toolkit. I don't know if any of you are familiar with that. There is that. And then the Visual Studio 3D starter kit that someone on the team wrote, Roberto Sonino. And that is what we will use for our demo today. You don't have to start over. If you have code already or you're familiar with C++, you can use C++. You can interface that using some of our, like C++ CX. You can make it available to some of your other managed languages. You can write your other parts in VB or C#. Probably a lot more C# people in the room than VB. You can combine XAML and DirectX in the same application. In fact, our app enables that. We don't actually throw any XAML up on the screen, though. There are examples out there. Developed for Windows Store, Windows Desktop, and Windows Phone 8. You don't have to start big. You don't have to start with Halo 4, right? You can start with a proof of concept. Work out all the kinks. Add new features incrementally. Hopefully this is sounding familiar. And then solicit feedback. I went ahead too fast. So let's see. Solicit feedback. So this is standard stuff, right? I mean, you don't want to bite the whole pie there at the beginning. You're going to want to start a little bit slowly. So following this, we're actually going to do just that. So let me show you what this looks like. Actually, I'm going to skip that. So, okay. So let's go into this. So this is the code part. All right. So what I'm going to do is I'm going to start from the beginning here. I did mention that I had an app here loaded. That's the one we're going to use for debugging. So what I did is I literally went out to a blog and found the modified, actually this is on Codeplex, I found a modified version for this kind of application available to anybody. This is something you can go grab, and I downloaded it here. What I'm going to do is I'm going to go ahead and extract it. Let's call it Die Roller Booyah. Yeah. And then I'm going to go ahead and rename this. I could have skipped this tedious part, but I wanted you guys to see that there is some stuff like this that you have to do. Okay. And then I always check to make sure the thing runs. Let's see what we get. If it doesn't compile, I'm in trouble. Nothing. So we got the splash screen and nothing. So this is good. This is exactly what we expected. I'm going to stop. Now, first thing we're going to want to do is, again, just a full disclosure here, I do have a script. I'm walking through this script. I didn't want to choke in front of you guys and remember, 20 different steps, so I do have a script here. So we did compile everything. What's kind of cool about this is adding a cube. We need a die, so let's go ahead and add a cube. It's kind of neat the way you do this. Let's see. So shared assets. I'm going to add a new item. I'm going to choose graphics, 3D scene. Let's call it die. So we've got this sitting here. Now I need to add a cube. Let's go take a look. Oh, grabbed the wrong thing, but as long as we're here, doesn't this remind you of like the MCP in the original Tron movie? I don't know, Master Control Program. So I did that just so I could mention the old school Tron. Yeah. Let's see, so I'm going to delete that and actually go pull a cube. Here it is. And then, I can do this, take a look at the cube, and then I can grab my grabbing hand here and do that. And then if I really want to look, yeah, there it is. It's a cube, right? There it is. And then what we need to do is save. I'm going to load it now. And this is part of the 3D starter kit. So I'm using stuff that's in the 3D starter kit to do this. And if I go a little fast, this is actually documented out online. And the format, so this is just a reference to the graphics object, and then this is a file you're actually trying to load. CMO is, It is compiled mesh object. You also have compiled shader object and compiled like images and things that are compiled into direct draw surfaces. Those are handled for you by the FX compiler. So that's all done. That's what these other directories here, if you've got supplementary support things for your mesh, that's where you would specify them. That's typically not something you would need to do, but there it is. And then we're going to render the scene here, and I'll do that here. So again, this code comes out of the kit. So when you guys get the code, the starter kit, you'll see that it looks just like this. I'm going to go ahead and compile, but I'm going to ask Control-Shift-B there. Is there anything, especially those of you that were in the class in my session on Tuesday, is there anything funny about that rendering loop? I mean, I actually copied this verbatim from a sample, and that stuck out to me. I'm not using range 4, am I? This is C++11. We should be using a range 4 there. So I'm going to actually convert that to a range 4 instead. Let's see what we have. There it is. Can I do anything with it? No. But it's there. We got something on the screen. Let's give ourselves a hand. Yay. This is a long way from Halo 4, by the way, right? Yeah. Let's stop that. All right. So we're trying to render a die. So that cube obviously has very little personality. It's just gray. So we need to slap a texture on it, right? So I'm going to go get a texture that we can put on there. And I'm cheating, obviously. I already had the texture here. And what I'm going to do is I'm going to copy that in to the assets. And then come back here. And then on this, I can click the cube and, let's see, was it Control? Yeah, okay. Alt-Enter brings up properties for the thing you're on. I didn't know that. It's something I learned. I'll do that. And then you'll see there's texture 1 here. There it goes. It's on. Let me do this, by the way. I also learned Control and mouse scroll zooms. I didn't know that. So we've got a texture on there now. And if we run it, there it is. It's kind of far away. We can move it a little closer, see it better. So that's what we're going to do. We're going to set the camera just a little bit closer. Let's do that. We can set that to 6, actually, and we can change this to 2. I will show you what happens if, well, there are, if you can play around with these values, X, Y, and Z, and shift the camera perspective around a little bit. That brings it a little bit closer. If we were to change some of the other values, we could get inside the cube, and that would be disaster land. Or we could change the perspective. But that is the front face there. It's at number 1 now. So we can pretend that we just rolled the die and it's sitting at 1. That's the number that's up. Okay. So this is the part that I want to talk about a little bit more here. What's interesting about this particular object is We applied a texture. Hopefully you guys can see that. We applied a texture, but it also has a default effect. It's got a Phong effect right now. If we were interested in changing that, you actually could change that by coming over here and clicking this, Advanced. You can come in here and actually mess with this, right, the shader. We're not going to. In a previous instance, you can actually, seriously mess up the way that cube looks by, for example, putting blue to the X here, or messing up some of these other paths. You can also make relatively sophisticated shaders. This isn't really one, but it's interesting to know that for mesh, you can associate a shader, a custom shader. It gives you one out of the box, when you specify, but you can certainly go in there and choose something else. What I wanted to do was, I want to show you what that looks like. Let's see, add existing. I'm going to show you, I got these from someone on the team, a pretty cool shader. So what I need to do here is, let me zoom in a little bit. This is pretty cool. Ooh, isn't that cool? That's what you can do with the shader. And what's kind of funny is if we had a little bit more time, you can actually apply that shader to our die, and it really looks kind of funky, right? It's got this storm on one side. It's really messed up, and the colors are weird. But this is the power of a shader. There are a lot more things that you can do with the shader. I'm not Mr. Shader, so I can appreciate something like this, but I haven't gone in and looked at the code. It's relatively sophisticated, but that's pretty cool. I like that. So let's turn that off. And there it is. Okay. Any questions so far? Ask again.
Is it a BREP, boundary representation, solid model, nerves, mesh, or polygon mesh?
I don't know the answer to that. I think it's polygon, but I don't know for sure. Anybody in the room happen to know? I can find out. Yeah, I don't know if it does that. Yeah, I don't think it does that.
So was that showing like a visual diagram representation of that FX file? Where you're showing
The globe?
Sorry, the shader that you were just showing right there. Yeah, was that like a built-in feature where it can like parse out that shader?
Yes. Yeah, that's a shader. Yeah, shader designer. Yeah. Yes, yes, and you can actually export. It's interesting, the evolution of this, when Roberto converts it to work on the phone, since there's a different version, there's an older version of DirectX on, I'm pretty sure it was phone. What you have to do is you have to go in there and export that Phong into HLSL, and then when it's compiled, the compiler picks it up and knows that it's got to compile for an older version, and it actually does that. But it is HLSL behind. Okay. So the die is just sitting there. It's not rolling. It's not doing anything really exciting. We need to make it do something exciting. I took a look at the graphics text and talked to some folks about animation. It all really comes down to if you watch Tom and Jerry or Bugs Bunny back in the day, right? I mean, it's all the same. You have to figure out what you're going to start, where you're starting your animation, right? Where Bugs Bunny's starting, where he's ending, and the steps in between. So that's really what we need to do here is we need to figure out how long we're going to be, what's the start and stop on this, right? We know the start. What's the stop is going to be the number that we want it to come up on. And then we've got to be able to render those in-betweens, right? In fact, in-betweeners, that was a job back in the day, right, at Warner Brothers Animation Studios. These guys, typically the key artists would go in there, like Chuck Jones would go in there and animate the keyframes. And then lesser artists would go in and render everything in between, knowing the start and stop. And then you also, it's not just enough to animate, as Walt Disney figured out. It looks a little metallic, or it doesn't look, it looks unnatural. So he sent his artists to study, like, you know, if they were animating an elephant, they went and watched elephants walk. And they learned that they had to exaggerate some things to make it look more realistic. So we're going to use some math to make this look realistic when it spins. It's not going to win the realism award, but we're going to go a step in the right direction. And that's where you can find that, depending upon where your interests go, you can learn a lot more about those types of, that area of math, right? So if you're going to go in and render things like this, and you'll need to figure out, you know, what does it look like when it hits a wall? What does it look like when it, you know, lands on a floor, falls off the table, things like that. So what we're going to do is, you know, we need to know where it starts, where it's going, and where it is now. So we're going to add our class variables to go ahead and track those things. So we're going to be able to roll the die, and then let's see here. So we're going to add a new method, and then we're going to add some private stuff. And then we're going to add our roll die, and I'll talk about this here. Let's see. So basically what this is doing is when we start our roll, we'll figure out where we are now. If we're on 6, we'll note the fact that our initial rotation is beginning with 6 showing. And then we're going to figure out where we're going to go. In this particular example, we're not actually rolling it yet. We're faking it. We're just going to go to 6 all the time. So wherever it starts, I'll be able to tap the screen. It'll go to 6, and it won't go anywhere else, right? So we're taking baby steps here. And then when you start the animation time, you know, we start at 0, and then we turn on a Boolean. So in the render loop, we know that we should be rendering. We're going to modify the update. Again, game update is part of the framework. So this is given to you, and there's a lot of work that's done on your behalf in the starter kit. There it is. So this is our loop. It's called, here, you've got the total time that you've been running and the delta, and that's used to figure out what we should display. So XM vector is used because it's faster. So you can load into that format, and it uses hardware acceleration. That's what I understand. I'm not an expert in these things, at least that part. But so what happens is you load these things, and then this is a parameterized function, essentially. If you give me a time, I can tell you what the thing looks like given that time. So it's just figuring out how much of the I've got 100% of time that I need to spend. Am I 80% of the way through? Am I 75% of the way through? And it figures out what that rotation looks like and applies a transform and makes it ready to go. So this is doing the calculation. We'll have to go mess with our render. So right before we render it, we've got a transformation matrix. We'll have to tweak the thing that we're rendering. So let's do that. And then the last thing we need to do is go to our touch. There it is. There. Now, if I haven't done anything horribly wrong, it should run. Let's see. There it is. So now that we've got that going, it just going to 6 isn't that interesting, right? I mean, I guess it's interesting if you want to go gamble against it, and I know the fact it's always going to go to 6, I might be able to get rich for a few minutes, and I'd probably get hurt for cheating. But so what we need to do is we need to make it random. And this is another instance where I've mentioned before in a best practices, one of the, in fact, the MVPs mentioned this, I've seen this in the past, is for every C++ developer, if you have 80 in a room, you'll get 81 opinions on how best to do something. It can be the simplest statement in the world, even formatting, right? You'll get 81 different opinions for 80 folks. So I want to go in and randomize this thing. You could use rand out of the C function, C library, or you could use a Mersenne twister out of the STL. So in the interest of being C++ 11, we're going to go for that. It was, developed in '97, and it's tested. Everybody seems to like it, so I think that we'll be reasonably safe using that. In fact, here, it gets rid of flaws for all you math folks out there. I know when I was in academics, we'd use random number generators in our lab for experiments with game theory with some human subjects, and we'd actually run the random number generators through hundreds of thousands of numbers and then go analyze and make sure we were good to go. So this has apparently had that level of rigor. So we'll go ahead and use that. So I need to modify, just to get the random stuff, I need to add that to our game header. And our instance. By the way, I stole some of this code from a forum post that Stefan Lavavev did. I just butchered his name. STL, I don't know how many of you guys know STL. He's a standard template library guy as well. So I took some of his code. And then in game, we are going to pull time in. And the reason we're going to do that is because we want to seed our generator. And we're going to use the time for that. And this is what we're going to do here on game. I don't think I broke anything. And then we're going to modify roll die. I'll just leave this up for a minute. What we're going to do is we're going to take the number first and, modulo 6. So it'll give you a number from 0 to 5, and then we're going to add 1 to make it 1 to 6. And then we're going to go into switch and figure out what our target rotation is based on the number that comes up. And that's just fixed, right? We have to do certain transforms to make it go to that. If I was a master of trig, I would go into that for you, but I'm not. So we're going to take that. And we're going to go to roll die. Let's put it here. That'll stop us from always going to 6. And we are ready to go. I usually have a bad habit. If it's like a nervous tick, I always hit compile and build and save all the time. It's just always do it. It's a bad habit I learned. So here we are. Let's see what happens. Anybody want to guess on what number is going to come up? I actually don't know. It's a random seed. 3, 4. There it goes. 6. Should be different every time. Let's see. Just to prove we've got a unbiased device here. That is interesting. I believe that's what we are doing. Right, but that, yeah, we are. So we're taking time. Let's try this one more time. Okay. So one thing my father always used to tell me, he was an economist and did some game theory. He goes, 6 could come up 100 times, but the die has no memory. So the next one, it's an equal chance of anything coming up. So I remember that when I'm at the roulette, you're walking by the roulette table at Las Vegas, they've got the little number, the little board that shows all the numbers that have come up. It's like, it's good, but that doesn't mean anything really. All right, so I think we're around that. That works. So there's a couple more things I can do here. It looks like we've got time to do it. I'm going to add we're going to make it go up in the air. And then we're going to add an extra spin to it, and I can blast that stuff in there. The way we're going to make it up in the air is this is actually math I can follow. It's relatively simple. We're just going to use a parabola. So instead of it just going up and down, kind of unnaturally, we're going to use a parabola. So it kind of goes up gently and then comes back down. It's going to stay in the same kind of column, but it's going to kind of go up using a parabola. So what we need to do is figure out what our translation y is. We're going to need a member variable to cover that. Let me copy that into game.h here. If only programming was this easy, just copying from a template. And then let's update our update here. Some people put consts at the top of a file. I know I used to do that. I tend to favor now this format where const, you set it more closely to where you're going to use it. So those of you that are C++ in the room, just throwing that out there. Let's take a look at the render. And then we'll move on. Update roll die. Let's just do this. And then we can send this away. Let's see what we've got. Let's see if it comes up to 6 again. So that's kind of neat. It still has a way to go if you want to make it bounce and fall off the table and move more than just up and down, but that is where we will end that demo. Not too bad, right? I mean, we did the standard things. We started with an object, and then we made it look better, and then we made it behave better. Not much different than making Bugs Bunny walk across and argue with Daffy. Although we don't have any audio, so there's another avenue. And just, I don't normally do this, but again, this is something I did, so I figured I would show you guys. And I can share this link. I ran across this when I was doing some research for the session. Gaffer on Games. He talks about modeling a Go stone, and it looks simple, right? But it gets very kind of interesting, right? So he uses 2 ellipses and goes through a bunch of math to model this thing, and that's the point where it's cool, but it takes effort, right? And a lot of people don't realize that something like a halo, maybe they do, but something even modeling a Go stone, this is without any physics of it moving. This is just modeling the object itself, can get somewhat hairy. Then he goes into tessellation and moving the thing, and with some detail. So if you're really interested in things like this, I would recommend you go out and take a look at something like that. It was fascinating. So let me go back. Any questions? So we have a prototype. We began with the Visual Studio 3D Starter Kit. A variant of that, it's available out on the web, out on a VC blog and in Codeplex. So you go to VC blog, you'll see it. Hopefully everybody goes to VC blog. We created the die with the mesh editor. We brought the die to life with physics and C++. Any questions? Oh, let's again.
Do you have a scene graph in DirectX now? Because in the past, you had to go build your own or use somebody's.
I don't know the answer to that either. I'm just coming up empty. I can find out, though. Other questions? Maybe one I can't answer? Please?
Before you always used X model format, and now I see the CMO. I think X was deprecated. Do you know anything about if they still use that, or CMO is going to be the new model format for DirectX?
I think that's what we're compiling into from an FBX, so I can't speak to what was done in the past. I don't know what they're doing with it.
I've seen a lot of where they just say come up with your own kind of things.
Okay.
Seems to be that's been more down.
So let's close this. So let's pretend that the app just landed in QA. I've got my QA hat on, and I'm ready to go. So I get the app, give it a run. There's nothing there. It came from dev, landed over on my environment, and I run the app. I know it's supposed to be really exciting, and I don't see anything. What do I do? Alt F5? Oh, file a bug. I'm going to go one step beyond. I'm feeling, since it's Thursday, I'm going to not just file a bug. I'm going to do some investigation. So I'm going to hit Alt F5 to start the graphics diagnostics. You'll notice up in the left, we've got some stuff. It says press a print screen to save. Frame is telling you the frame it's on, how long it's been running. So what I'm going to do is I'm going to press I'm just going to pretend like it's working and hit print screen here and see if I can capture some data. And then when I'm done, go back to the app. So let me debug graphics. So I'm taking a look at the events list that it captured. I don't know how well you guys can see this. But it gives you information about everything that occurred, lots of things that occurred. One of the more useful things that you can take a look at in terms of debugging, and this is something that some of our internal developers told me and some folks on the UA, the writing team, said that one of the more common problems you will have is that device initialization. So this tool will allow you to go in and take a look at the device initialization and see what's going on there. Maybe there's a misconfiguration, or you've got back to front set wrong, or the spin, right? So vertices can be interpreted clockwise or counterclockwise, and if you've built your objects with one and then told DirectX the other, stuff will look really bad. And this is the way that you can figure that out. There are some other kind of general things that you should look for as well. And I'm going to point you to online information. There's a lot of stuff for diving in specifically in a device context. But let's take a look. So the device context looks fine. We got an image. Let me look for draw. See if there's any draw here. So we don't even have a draw. That, it makes me wonder, what's going on. It doesn't look like a draw call was ever invoked. So I'm gonna use that and my previous knowledge that I broke the thing, so I know where the error is. Don't you hate it when people act like I don't know where the error is? Well, okay, I made it. I know where it is. But it's based again on comments. So what I'm going to do is, and I think I mentioned this before, is let's see here, initialize. Let me find the initialize. Here it is. So here, I guess that would help. I specified, the asset name is wrong. And this is common, right? I was really surprised. This is a common problem. This isn't, I mean, it seems so simple to go out and mess this thing up to do this, but this is actually something that happens. So we fixed that. Let's give it another shot. I'm going to close this one. Don't want to save it. Alt F5 again. Still don't see anything. So let's tap and take another grab here. So I hit print screen a couple times. It said it captured the frame. I'm going to go back and take a look. So I've got my events list. Let me see if there's a draw. There is a draw. Okay. There are a couple things I want to show here. First, I don't know if you guys can see it, but there's it's complaining up at the top. We're using multi-sampling, and our pixel colors may go off. And this really happened when I was using the kit, and I didn't want that to continue. So the first thing I did is, after I saw this, I stopped and went in and tried to figure out how to fix that. So let's go do that. We can turn off multi-sampling. So what I did, and I'm not an expert, is I just typed in multi-sampling, told it to search the entire solution. Multi-sample. So this looks suspicious, right? Like I should be able to say false there. Let's see. Of course, since I asked the question that way, you guys know it's not going to work. Didn't work for me either when I tried it. And then I went and asked Roberto, who is right down the hall, which is a benefit I have because I work right down the way from him. That's not where you need to fix it. There's another example of multi-sample here. So what we want to do here is, in this, is trying to figure out what level of multi-sampling you can support. It says start at 4. What we're going to do is we're going to tell it to start at 1, and that'll turn it off. So let's run it now. I will touch and grab it again. And then, so we're on the draw here. Then I'm going to look at pipeline stages. This is really cool here. So here we can see that something is being assembled here. We've got a vertex shader applied to it. It just went big on me. Let's see. And lost it here. So it looks like something's being drawn, right? It looks like something's being drawn, whereas before we didn't have anything being drawn. So our task, if we choose to accept it, is to figure out, do we have another bug? And of course we do. And it is, I'm suspicious of the camera, right? I mentioned this before, that you can set it around. It looks like someone made a mistake, and typed in -6,000. So there's an object there. It's just, it's around the world. We can't see it. So let's see. Let's see if that fixes it. There it is. Oh, it's going the wrong way. Dope. So let's, so I can grab that again, although the graphics debugger isn't really going to help me here. It's obviously a logic issue. And, where do we calculate that? It was roll die, I think. Let's go take a look there. Solution, roll die. Actually, it's probably an update. So here it is. So yeah, I cheated here. I made it negative. That's another kind of common mistake. And these look contrived because it's a contrived sample, right? I mean, most of the things like this are very contrived. But again, based on customer feedback and talking to developers, and game developers. There's some folks out there, and they've given us feedback that these are the kinds of things that they track down. They also track down, gee, some pixels don't look good, and among millions of pixels, and that's a challenge as well. So let's see if this works. But this is a logic error, and hopefully we fixed it here. So we did, and it came up 5, not 2. 5, 2, 3. Excellent. Any questions? Oh. Oh, yes, yes. So I'm going to switch back. So there are a lot of graphics debugging scenarios. I think I went through some of these. See how the device is set up. Look at all DirectX events for a particular frame. See a draw event move through a graphics pipeline. You can see where it's being messed up. If you wrote your own shader, a lot of times you'll be able to see this. The call stack. See how a pixel has changed, which is kind of neat if you've got a complex scene that you're rendering. We did not, but there are some other samples out there on the web that you can run, and you'll see a complex scene. You'll see some pixel in, like on a tank or something, is just not right. And you can actually see how the pixel came to be. It's pretty detailed. And then step through HLSL code and analyze 3D objects and resources. Primary ways to debug are to capture locally using the Visual Studio Graphics Debugger. That is what I showed you. And to capture remotely using a Capture API, there is online documentation for that. How do you start graphics diagnostics? Everybody should know this. And debug graphics, start diagnostics. We actually already did that. So how do you extend the app? We could add more die and supporting objects, a table, a bumper. Again, we're showing probability. You'd probably have some support text, some explanatory lessons, things like that pop in, add some context. You can spice up with ambient sounds and music, increase interactivity. Maybe you shake the thing, but don't make it fake, right? I mean, I was playing Uncharted on a machine, and it had you, I don't know, rub things and something. It's like, oh, come on, this isn't part of the gameplay. So make it part of the play. Don't make it a chore. You can learn more about deploying this app with Robert Sonino at that. I don't know if you guys have used http://aka.ms. It's a shortener. If you follow that, you will learn more from the man himself. He also has a video, and he talks about deploying this on other platforms. And we have an interview on Channel 9 that Roberto did with the man behind Virtual Experiment Lab, and it's fascinating. So again, it's a real-life, real-world developer experience behind developing with this kit on this platform. And I'm a community guy. I'm going to pitch for the community here. Learn more. There are physics libraries, image tools. There are a host of things out there. Just be aware. Samples, code snippets, frameworks, discussion, advice, feedback. We have a Facebook account. We're on Twitter. A lot of our MVPs are also on Twitter and Facebook and blog prolifically. And they respond. So if you tweet or you want interaction or you have a question, they will respond. Contribute and share your experiences, and assume good intent. It's something I always throw out there. It's kind of tough when you're in community. When someone responds to you, you might want to interpret it as, like, why did that guy respond to me that way? I didn't do anything to him. One of the things that makes community work is you just have to assume that everybody's out there to help. That there aren't hostiles, right? That people aren't intentionally trying to, unless they are, right? It depends upon what community you're in. But these types of communities, they're very friendly, and it's just something that sometimes can be tough, especially if you're doing a shared contribution, like on code or a wiki or something. If someone goes in and modifies your thing, it's like, well, it was perfect before. So you have to assume good intent. I know it's something we all learn when we're younger, but it's kind of tough sometimes. Just be nice. Pop quiz. So I've got major swag here, major prize. I've got 3 shirts. I've got 3 questions. Who was first? Who wanted the? Okay. Oh, watch out, people. Oh. I think I heard it here first. No. Can someone name a place? Oh, nice. Who was first? What's the flight speed of an unladen? Nice. All right, so I think we're at the end here. Let me see. I don't want to. Okay, so here, blah, blah, blah. Yeah, you want to go do this. You definitely want to do this. That's nice. Here, there's some resources. Let's see if it's going to play the animation. Channel 9. Do this, please. Please, please, please fill out the evaluation. We love the feedback, especially if I did something wrong or slow, I'm annoying, my hair's too long, whatever that feedback is, it's constructive. It'll make sure that the next time I give this talk, I'm better for the next people that come along. So definitely do that. We also have track people that take a look and see how well we do, and they give us frowny faces if we fall below a certain level. So good or bad, please give the evaluation. Is there something else here? And there you go. You can scan. Are there questions?
How do I find out more about that graphical shader pipeline that you displayed?
That's a great question.
And then there's a follow-up.
So I will point you to the blog, because especially this, you can see developing an app. This is part 3 of 3. Roberto does point into the MSDN documentation. We have very good documentation that gives samples on just that. There's walkthroughs. In fact, I modeled some of my talk on some of those written samples. Our documentation, the C++ guys, I'm going to show for them again. The writing team is phenomenal. They're very experienced, and they have good stuff out there.
And the follow-up was this whole, if it runs on my PC, Windows 8, DirectX 11.1, it'll run on the phone. The scene part, maybe not the handler.
You have to make a little bit of changes, and Roberto actually walks through some of the steps that you need to do to make that work. Anything else? Thank you.